Today we're going to start off by learning how to solve a piecewise function. To start off the problem, we're going to have to do the first part of the function. The first part is saying that any number less than or equal to 3, we're going to have to plug it in and graph it. So first we're going to start off with the number 3. 3 squared is 9, and you add a negative, which would be negative 9. So add 3. You'll go all the way down to negative 9, and you'll make a point. Next, you're going to do the number 2 because it's a number less than 3. You're going to do 2 squared, which is 4, and then add a negative, which is negative 4. At 2, you'll go down 4 places, 1, 2, 3, 4, and you'll graph a point. Next, you're going to choose a number 1. 1 squared is 1, and you add a negative, which will be negative 1. So at 1, you'll be negative 1. Next, you're going to do 0. 0 squared is 0. With the negative is still 0, so at 0 it'll be 0. Next, you're going to do negative 1. Negative 1 squared is 1, and you add the negative, which will be negative 1. At negative 1, it'll be negative 1. At negative 2, you're going to do negative 2 squared, which is 4. With a negative, which will be negative 4. So at negative 2, you go down to negative 4. Next, you're going to go to negative 3. Negative 3 squared is 9. You add the negative, which is negative 9. So at 3. At negative 3, you're going to go all the way down to negative 9. Finally, you graph it. You add the lines to it. And here's your first part of the function. This part is saying that at y this will be 5, and because there's no x here, it's going to be a constant at 5. This x is saying that any number in between 3 and 8 will have that constant line at 5. So at 3 is going to be an open circle, and at 8 it's a closed circle. At 8 it's a closed circle because under the less than sign there is a line underneath, which means that it is equal to 8. When it is equal to the number, you have to circle it in. The 3 doesn't have the line, and it is open, which means that it can't be equal to 3. Now you're going to draw a line from 3 to 8 at 5. And this line means that the second part is a constant. Function is saying that any number greater than or equal to 8 is x. So we're going to plug in 8. 2 times 8 is 16 plus 3 is 19. So at 8, we're going to go all the way up to 19. We're just going to plug in and write 19 next to it. It is a closed circle because it is equal to 8. Next, we're going to do 9. 9 times 2 is 18, plus 3 is 21. So we're going to go to 9, and then go all the way up to 21. Next, we're going to do number 10. 10 times 2 is 20, plus 3 is 23. So at 10, we're going to go all the way up to 23. And that's it. Everything. You go down here and you see domain, range, and behavior, symmetry, discontinuities, and asymptotes. The domain in this case is going from negative infinity to infinity because on the x-axis it goes from down here at negative infinity on the negative side to positive infinity over here on the positive side of the x-axis. For the range, in this case, it's going from negative infinity down here all the way up to 0. There's a bracket at 0 because it can be 0, as you see from the filled in circle. Next is a break, and then it goes to 5, and only 5 because at 5 it can only be 5. It's a constant. And then there's a break. And then it goes up to 19, and there's a bracket because it can be 19, and then it goes all the way up to infinity, and it keeps on going. Next is the end behavior. The end behavior is saying what x will be when it goes to infinity and what it will be when it goes to negative infinity. In this case, when it goes to infinity, the graph also goes to infinity. And when it goes to negative infinity, the graph goes down to negative infinity. On this graph, there is no symmetry because on this looks like it's symmetric, but there's no lines like these on the other side of the x-axis. Also on this graph, there are discontinuities. There are jumps at x equals 3 and x equals 8. You can see these jumps at 3 here when it goes from negative 9 all the way up to 5, and at 8 when it goes from 5 to 19. Discontinuous. The graph is discontinuous because I have to lift my pencil in order to draw these lines up here. For the function to be continuous, I would have to be able to draw the function without lifting my pencil. There are also no asymptotes either. And that is the end of this function.